Hello everyone, hope you guys are doing well and a Merry Christmas to all of you. So today we will be starting with another um, programming language that is Python, and then we will be studying some libraries such as NumPy, Pandas, and we will be performing data wrangling with using such libraries. Okay, so I will be referring Python for data analysis, data wrangling with Pandas, NumPy, and uh, what is IPython? It's basically that we will this an IPython. Now, what's the difference between Python and IPython? That we will like discuss later on. But this book is by O'Reilly, and we will be referring to this book. Now, what is kinds of data? When I say data, what I am referring to exactly? So when I mean data in terms of data analysis, what type of data? Data can be anything. For example, I can comment under a YouTube video, even that is data. That is a textual based data. Same. So what we would be referring here. So the primary focus here is basically the structured data. Structured is basically a vague term. It's basically a very general term. Now what does that comprise? Tabular or spreadsheet data, which in each column may have a different type, that is storing numeric data. For example, the most common type of database here is a tabular data is RDBMS, relational databases, wherein you have two tables and then they are interrelated by each other with the help of some keys or foreign keys. And we use MySQL to interact with that data as a DBMS or a database management system. Now then, building on that, there can be different types of data, storing numeric data and otherwise. Now that this includes kinds of data commonly used in RDB relational databases or tab or commas delimited text files. Now we can also have data instead of having columns or instead of having lines, we can have comma. Then data can also be represented as multi-dimensional arrays or matrices. Multiple tables of data. Again, this is what I meant by RDBMS. This is by no means a complete list, even though it might not always be obvious. Now, this is not a complete list. There might be other types of data as well. Even though it might not always be obvious, a large percentage of datasets can be transformed into a structure. Now, what it's doing is we can transform them into a structured form. For example, even if it's like a text file separated by a comma, they can still be transformed into a structured form. If not, it may be possible to extract features from a data set into for example, we need to we have a data, and then for example that is all random, and using that data we will be doing something called as extraction and converting that entire data set, not converting that entire a part of that data into something like a table, like into a structured form. For example, Microsoft Excel. Again, news articles could again a collection of news articles can be accessed into a frequency table. For example, which article is viewed the most, like which what keywords are going in when people are seeing that article. As an example, a collection of news articles could be processed into a word frequency table. Now, for example, what words have been frequently used? What are the other alternatives that can be possible? Most users of spreadsheet programs like Microsoft Excel are most widely used data analysis tool in the world. We still will not be strangers to these kinds of data. Now, why Python? So then the question arises, why to use Python for data analysis? Why can't we use any other programming language like JavaScript? Say, the thing is, for many people, the Python programming. Now, why? Why is the question here? Now, it was first appeared in 1991. Python has become one of the most popular interpreted programming languages, along with other languages such as Perl, Ruby, and others. Now, Python and Ruby have become especially popular since 2005 for building websites and numerous web frameworks such as Django. Now, Django is a Python again framework. Now, such languages are often called as scripting languages, and they can be used to write quickly small programs or scripts up to automate tasks. They help in other the using a small piece of code we can do a large number of automation. Automation is wherein the computer automatically logs it. I don't like the term scripting languages. It carries a connotation that they cannot be used for building serious software. Among interpreted languages for various historical and cultural purposes, Python has developed a large and active scientific computing and data analysis community. Now, since the last 10 years, Python has gone from a bleeding edge to at your own scientific computing language to one of the most important languages for data science, machine learning, and software. So, initially, Python was considered as a very uh, risky language, but then considering the vast amount of support that we have, for example, uh, Python will it will be so like instead of Python we can use languages such as R, Matlab. These all SAS. These also will provide us with many mathematical and computational power. In recent Python's improved the reason why we are using Python is the support for libraries such as Python, such as Pandas, NumPy, Scikit-Learn. These are all libraries, and the popular and the support for these libraries is in Python. And since these libraries have been worked upon, like by since the support is huge, since the support for these libraries is very huge, therefore, combined with the overall strength of the Python and the libraries that support it, generally we use Python for data analysis. Now, part of Python's success is in scientific computing. Now, why it is called as why it is fast. Most modern languages environments share a similar set of legacy Fortran and C libraries to do linear algebra, optimization, integral FFT, and other such algorithms. The same story has held true for many companies and national labs. The most programs consist of small portions of code where most of the time is spent with large amount of glue code that does not run often. In many cases, the execution time of the glue is insignificant. Effort is most fruitfully invested in optimizing the computation bottleneck, sometimes like borrowing code to a lower language level like C. Now the problem is it's very easy to using Python we can easily integrate C++ and Fortran code. Now the advantages of these um, languages they are very computationally faster. They are optimal for integration, FFT, linear algebra, and other such algorithms. The same story can be held true for many companies and national labs that have used Python to glue together decades. Many programs consist of small portions of code where most of the time is spent with large amounts of glue code. Glue code is that code that does not run. In many often cases, the execution time of the glue code is insignificant and the effort is most fruitfully invested in optimizing the computational bottleneck, sometimes like by moving the code to a lower language. Now see the problem is this glue code is not run many times. Many times the execution of the glue code is insignificant, but the effort is most fruitfully invested in optimizing computational bottlenecks by sometimes moving the code to a lower level language like C. Now solving the two language problem. Now in many organizations it is common to research, prototype and test new ideas using a more specialized computational languages like SAS or R. These are more computationally fast and then later put these ideas to be a part of other production systems that are written in Java, C++ or C hash. Now, what people are increasingly finding is this Python is not only a suitable language, not only able for prototyping but also for building the production developed system. So the advantage is when I use SAS or RTA, these are basically only computational languages and not and you cannot be deployed. For example, we have frameworks such as Django, which this can be deployed as well, right? So there is so the problem here arises is we need two developers. One is a person who is a Dart developer who is going to do um, the, the 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 mathematical portion. The other is something a person who needs to be a Java, CS, or a C++ developer who is going to build a website. So and then we will need a third person who is going to integrate the codes. You see, the number of people required here are more. For example, with Python, what advantages? Although like we may still have some separate teams, but then it's easy to port codes when the language is the common, right? The development language is Python, then the computation language is Python, and then it becomes very easier to do that, and it's very portable. Like it can be, I mean, if there is any error or bug, it can be resolved very fast. And why not Python? Now the other question arises: why shouldn't we use Python? While Python is an excellent environment for building many kinds of analytical applications, in general, there are a number of uses for which now where Python cannot be used. The Python is an interpreted programming language. Now, what do you mean by this? We'll study later on. In general, most Python code will substantially run slower than the compiled languages like Java or C++. As programmer time is often valued than CPU time, many are happy to make this trade-off. Now, what he is trying to say is it is easy to write code in Python. It's more English-like code, like lesser lines, and still the code functionality will be the same. But what happens is computational time of Python is more. So here what he's trying to say is even though Java and C can take less amount of CPU time, but they will take more amount of programmer to write everything. However, in an application with very low latency or demand, for example, I say what if we need to develop an application that should run very fast. So then we cannot build it in Python because then we will need a low level language to do that. For example, an embedded system for real time RTOS. When we are developing RTOS, we need something that can run very fast and uses can be utilized because you might have different peripherals connected, right? One can be a timer, an input, an LED. So in those cases, C++ or C is considered to be used. The Python can be a challenging language for building highly concurrent multi-thread applications, particularly applications with many CPU-bound threads. The reason for this is that what is known as the global interpreter lock is a mechanism that prevents the interpreter from executing more than one Python instruction at a time. The technical reasons for why GIL exists are beyond the scope of this. While it is true that there are many big data processing applications, a cluster of computers may be required. Now, what is multi-threading? Now, this concept comes from this is an operating system concept, concurrent. What do we mean by multi-threads? Now, instead of having a single threaded program, what do is we break down the program into multi-threads and assign it to. So these days we have many cores, right? Now each core is a unit of ALU and CPU, arithmetical logical unit and computer processing unit, CPU. Component is basically to do it parallelly. Like we have two CPUs, you do the processing parallelly or concurrently. A multi-threaded is instead of having the same the program run on one CPU or ALU, you split it into such as if I have four cores is four CPU and ALU. So I make divide the program into four threads so that all of the threads are working. Now for such application, Python can be a bit challenging. The reason is something called as a global interpreter lock. You will learn what is this when you go ahead. Now Python cannot execute truly multi-threaded parallel code. Yes. Python C extensions that use native multi-threading can run code in parallel without being interpreted by the G. Python does not. There is something called as Python cannot do multi-threading, multi-threaded or a parallel code. However, there is something called as there is a Python C extension uh, that uses native multi-threading that can run code in parallel without being impacted by the GIL, as long as they do not need to regularly interacting with Python objects. We'll see what Python objects are. Now, essential Python library one is NumPy, or numerical Python. It has been a long. The first library that we need to study here for data analysis is NumPy. A short for numerical Python, long conversion of numerical computing. Advantage is faster. Yeah. So whenever we have multiplication of two matrices, right? Two n-dimension matrices, that is done very fast. Tools for reading and writing array-based data sets to disk. Okay, linear algebra, FFT, and other random operations. A mature C API to enable Python extensions and native C or C++ code to access NumPy data structures and computational facilities. Beyond the fast array processing capabilities, now the major advantages we have fast array processing capabilities. NumPy adds to one of its primary uses in data analysis is a container for data to be passed. For okay, so other than for data array processing, the other uses is data analysis as a container for data to be passed between algorithms and libraries. For numerical data, NumPy arrays are more efficient for storing and manipulating data than the other built-in Python data structures. Also, libraries written in lower languages such as C or Fortran can operate on the data stored in a NumPy array without copying data into some other memory representation. Okay, so then again what I is trying to say is why. So you can directly operate on data without creating another data, storing it there, and then copying, operating thereby, and then operating thereby, pasting a certain part of some part, and then by using certain memory. This may numeric this many numerical computing tools either assume that NumPy arrays are a practical data structure or else target seamless inter interoperability with them. Hence, NumPy arrays are considered as the primary data structures. That is basically a way to store the data. Pandas. Now again, Garden provides again high-level data structures and functions designed to work with structured or tabular data, fast, easy. It easily blends with NumPy. Now what the advantages is, um, yeah, we can handle time series data as well over here. Arithmetic operations can reduce that preserve, and we can do we can merge and other relation which is found in popular databases like SQL. Okay, so basically NumPy is basically storing everything into an array. Not just Pandas blends into this idea of performing uh, manipulation. Yeah, so NumPy is basically store the data into array. Pandas blends, like Panda uses the NumPy arrays. The by what is saying is, and then we can do sophisticated operations such as we can reshape, slice, dice, aggregation, selection subsets of a data, perform data manipulation, cleaning. Again, it is one up of, for example, if you have null values where there should be a value, we need to perform certain cleaning, right? So for search operations, Pandas is important. I wanted to be able to tell you all of these things in one place. These are the reasons for Pandas. Python was a good candidate language for this. Now I wanted to be able to preferably language well suited for general purpose software development. Python was a good candidate language, but then at the time there was not an integrated set of data structures and tools providing this functionality. As a result of being initially to solve finance and business problems, Pandas features especially deep time series will suit for working with. So the major advantage is this, like you can work on time series data. This is something. For users of our language, statistical computing, the data frame will be the simpler. Unlike the object was named after the similar R data frame, Like pattern data frames are built into our programming language as it's a standard library. As a result, many features found in Pandas are typically either part of our core implementation. So R has been then implemented on Python. So then that problem goes off. Why you need to have R or something? Why do you need to study R separately, right? When the code is already being used. Matplotlib. This is basically another very good library. This is for visualizing, like for drawing graphs. Originally created by John D. Hunter, now it is maintained by a large number of developers. Again, this is the guy who piloted this. Most popular library for plotting, for two-dimensional or three-dimensional. We will be always using Matplotlib. It is now main trained for a large amount of development designed for creating plots suitable for publication. While there are other visualization libraries available, this has been generally termed as a very good choice. There are other libraries as well you can do visualization. Let's so basically what he's trying to say is um, NumPy Pandas so NumPy is for using the n dimension array. Pandas is built on top of NumPy, and we can do uh, cleaning is very important. The main purpose is to perform mathematical operations here. Pandas is for cleaning, for data manipulation and cleaning, and then Matplotlib is for plotting. So let's not open a folder, have a new text file here. You know what? We can, but we will have to create one here. Let's minimize, and then let's just have a new folder. Let's rename this to, or we can do that as, oh, I could do this. I can be using the command prompt itself. Have used for loops. I need the terminal. Okay, so let's do ls. We need to go to desktop. We need to create one. So what's the command for creating a file? In Linux's command is Dutch or mkdir, make a directory. And we make a directory, Just to make sure we are in desktop, right? Okay, make a directory called as let's move to that directory. Oh yeah, Python SciPy. This is a tab. Now we are going to this. Now we are going to make another folder saying day1. We have a folder day1. Let's do okay, let's go into this CD day1. Now let's create a text attach. Text. This can be notes.txt. Now I got a CD. Sorry. Where did I and why did I go back? Let's go to this one. Let's go to Python. Let's go to the string art. Okay, no spaces. Moving here. Let's do this. Let's do how to open this sketch. I forgot. Cat. Oh, maybe I feel cat. Hello, cat. What the hell is it? I can fire, open. No, I didn't open this folder, right? You know what? Open this folder. And then reset to folders. Go to day one. And the terminal open. Then the first thing that we started is why Python. First reason was library support. Can make both backend and frontend. Can design then do we have any other reason for this? It is an interpreter. Also, yeah, these two should be enough. Then we say NumPy versus Matplot. So first is NumPy. NumPy is for operations on the array. Then we say Pandas. Then we need to perform data cleaning and other processes. Again, we need support Matplotlib is plotting. Like these operations can be like multiplication and division, not division. By operations, we mean multiplication of NDIs, addition, subtraction, and so on. Now it is IPython. Now the IPython project began in 2001 as Fernando Perez's side project to make a much better interactive Python interpreter. So in 2001, this guy named Fernando Perez, I don't know whether I'm pronouncing it correctly, decided to make a better environment for Python. In the subsequent 16 years, it has become one of the most important tools in the modern Python data structure. Yeah, why does it not provide any computational data? It handles IPython designed from the ground up to maximize the productivity. It has both the interactive computing and software development. Basically, IPython is kind of an interpreter, editor. We have certain features such as edit, compile, run, other workflows. We have file system, easy access to operating system, shell, So instance one of the rating operation involves exploration, trial and error. Python can be a very high. Python can help you get the job done faster. In 2014, Fernando and IPython team announced the Jupyter project. So these guys have then developed the Jupyter. The broader initiative to design language agnostic tool, blah blah blah. IPython web notebook became the Jupyter notebook. So IPython is kind of an interpreter, then was merged with Jupyter. It has more. It cannot be now. It can be used as a kernel. Okay, for using Python, and this is very important. Kind of becomes a core part of the operating system. IPython HL Super has become a component of Jupyter open source project, which provides a productive environment for interactive and exploratory commercial computing. It's also oldest and simplest, modest and enhanced. Python shell designed to accelerate the writing, testing, and debugging of Python code. You can also use the IPython system with the Jupyter notebook and interactive. Also, the Jupyter notebook allows you to author content in Markdown and HTML, providing other means. Okay. So SciPy is basically a colleges of collection. Okay, first let's see what's this IPython. IPython as a IPython is a interactive interpreter as in by someone. Yeah, so normal Python won't have the support, right? We have certain magic commands. You can do something like history checking, logging. You can do multi-line editing. To check, Python by default comes installed in. Oh, this is not. Let's check here. Python, I can really already. No command one. How to Python hyphen, right? Python hyphen doesn't work. Hey, it's either you can type hyphen version. Now I got it. Python hyphen version. Command not found. Why I'm not getting command? Let's put it here, right? Let's start Python 3. Python 3 hyphen. Something's. Oh yeah, we have Python 3. IPython something. I can just do this. Yes. So whenever I refer to Python 2, so now if I say Python hyphen version, yeah. So not just alias or given I'm not sure now. So if I do Python hyphen version, no. So that alias will work only when I have just configure it so that every time I refer I don't need to mention. And I need to do control X. Yes. Tab to complete. Control T or control A. Yeah. This is all my files. Let's close the shell. Do you want to terminate? Yes, terminate. Oh, if I just do this, what's going to happen here? Command from alias is needed. Alias, alias, alias. You know what? If you want to refer to this Python Java Python, you can create an alias. That's okay. Without home, bro. Without bro. You can go down. The thing is, I need to update this configuration thing. Okay, it's not. This is the official version. You can download from here. Python 3.1. Always download the LTS version, the long-term support. Okay. Okay, we were studying what's the difference between Python and IPython. And then later on, they did IPython. What is a notebook? Because the way it is. Oh, line by line, like a notebook. Yeah, it is kind of done like. Does it do line by line? Yeah, I guess it was that line by line thing. Or cell by cell. Each cell contains multiple lines of cell. Because of this, is it a number? Okay, so think the cells as they are individual pages. So whenever we write in a cell, we are working in that specific notebook. So cell, okay, now again thing. So let's, when we came across IPython, IPython was this a special interpreter. Developed by a special man. So Jupyter and it's Jupyter though. Jupyter is a planet name though. Oh, so it has all the support. Yeah, now it can be used in any other languages. It can become. It started with J, Peter. The largest planet. So what does Jupyter provide? Since Jupyter already has Python, what's like the use? Let's break down this Jupyter kernel more details. So kernel is basically an kernel is basically which acts as a layer between the OS and the user. Yeah, kernel is basically, I mean, dots and letters are between things. And what advantage does this give you? Over I mean, why is it useful? Like, you also can, extensions can be done here. Yes. Like even if I download the extension here, I would still need the runtime here. So when we run in, we need the runtime language, right? For example, if you don't have the runtime, then it wouldn't work. We need the JVM. You see, let's, how does VS Code? Does not have its own. So integrate, at the end it will basically go on the OS. The extension is kind of an interface to connect the VS Code to the system environment. Also there we do not need to have the, so it, the running time are also, you need to download, but in VS would we need the runtime. This difference between and then we have VS Code versus VS Code runtime installed in the computer. Extensions are interfaces between VS Code and runtime. When I have a Jupyter notebook, consists, and then when I say by notebook, no need to download this immediately. This is your page. Let's now attempt to download uh, let's download Jupyter and see how does the user interaction behave. Should we try it? Okay, the next thing that we have is SciPy. Now SciPy is a collection of packages addressing a number of different standard problem domains. So we have SciPy that is at a certain number of packages addressing a number of different standard problem domains in scientific computing. Here is an example: SciPy.integrate, SciPy.learn, SciPy.optimize, .signal, .sparse. Together, NumPy and SciPy form a really complete and mature. But then again, there is something called a Scikit-Learn. So in this Scikit-Learn, there are already machine learning algorithms we have already being stored over here. Again, Statsmodels, Scikit-Learn, and there is something. There is statistical analysis package that was executed by work from Stanford University. The statistics professor Jonathan Taylor implemented a number of regression analysis models proposed in the R programming language Skipper. What's all different between SciPy and NumPy? Like what does SciPy do? SciPy. When to do SciPy? When to use? What's the difference between SciPy and NumPy? And basically, any operational matrices will be related to NumPy. If you want to do advanced for example, F50, this is present in SciPy. Okay, then we have another thing called as then we have SciPy, scientific Python or scientific Python. Yeah, this has what do you say? Advanced functions like F50. NumPy can NumPy to 50. Sparse matrices. What is the sparse matrix that we will do later on? So everything, so all everything. 4 is the NumPy. Is the NumPy array. There will be pandas. Everything is. NumPy is basically that thing that will have that array. We have something called as NumPy is already been discussed. I think NumPy is basically the core. This is the core basically. Like this is the heart. And then we have something called a Scikit-Learn. Scikit-Learn has Scikit-Learn has machine learning algorithms. Yeah, yeah, we have various algorithms in Scikit-Learn. as algorithms, ML algorithms. So basically, let's like get the work. The workflow is uh, store data in array and perform array based operations using NumPy. Then Pandas is cleaning that array, and SciPy is for more advanced mathematical function like FFT. Matplotlib is for plotting, and Scikit is ML algorithms. Yeah, this is how we would be doing it. Pandas is again for cleaning. Then SciPy is advanced MMT, FFT, something like that. Matplotlib is for data visualization, and then Scikit is for ML algorithms. So yeah, that is how the flow is. This is how the complete workflow will look like when we actually build something. Stats model is a this is stats model. Stats model is a statistical analysis tool that is succeeded by Stanford University professional named Jonathan Taylor. The regression analysis model in the language skipper. Okay, but regression can be done in Scikit-Learn as well, right? What is Scikit versus Statsmodels? Like, what's the difference there? Scikit-Learn is for machine learning algorithms, supervised and unsupervised both. But this we'll be using for hypothesis testing. Stats model, yeah, this is a intermediary. Before we have some specialized models in here as well. There is some difference, and so when to use stats model? So when you do formula based modeling, you use this. This is preferred one. Okay, that's cool. This one can be the same. Can we get the same thing but use cases? This is how to install. In Python, we already have this runtime in Mac. So yeah, there are other IDs as well for Python specific thing. JetBrains. Python 3 is already there, so we need to jargons. Yeah, these are the conventions generally for video implies. Convention is something that is um, generally followed. Okay, so I guess let's install the Jupyter notebook. Maybe no, not on this. Yeah, that's all for this lecture. In next, we'll start with installing the Jupyter notebook, and then we will proceed further in Python. So that's all for the guys. Again, wishing you guys a merry Christmas, and yeah, happy New Year 2025. See you soon. Bye bye.